All right, so in this video, we are continuing from part 1, where we're going to do now pH calculation for strong base and weak base. All right, so when we talk about pH, that pertains to hydrogen ions. But pOH, if you want to know about the concentration of hydroxide ions, we find out about OH, which is pOH. So you have pH for hydrogen ions, pOH for hydroxide ions. So if we want to find pOH, that would be negative log the concentration of the hydroxide ions. Now we know the pH scale, it stops at 14. Below 7, that is due to hydrogen ions, and above 7, that is due to hydroxide ions. So we have the formula pH plus pOH is equal to 14, and we're going to see how it comes into play. So the first thing we're going to do is find pOH. The pOH is equal to negative log .01. And the answer is 2. But this is pOH. You want pH. So pH is equal to 14 minus 2. So pH plus pOH is equal to 14. So pH is equal to 14 minus whatever pOH is. So pH is 14 minus 2, which is 12. And of course, the pH, it would be above 7 because it's a solution of sodium hydroxide, which is a strong base. All right. So if you want pH of a base, you're going to work out the pOH and subtract it from 14. All right, now there's a second equation that I want to show you that you can use to do this calculation. So there's an X constant, right? Kw, right? Ionization constant for water. Again, I'm just introducing you to the equations and how to use them. So Kw, it's equal to the hydrogen ion concentration times hydroxide ion concentration. Remember, Kw is ionization constant for water. If water dissociates, H2O dissociates, you will get the hydrogen ion and the hydroxide ion. Right? So that is where the H and the OH comes from. So if Kw is equal to H plus concentration times OH, we can transpose this to get the hydrogen ion concentration. So you would simply, I'm not sure this is recording. All right. So you would simply divide by the hydroxide ion concentration, because in this case, we want to find the H plus concentration. And whatever we do to one side of an equation, we're going to do it to the next side. So the H plus concentration is Kw divided by OH. Right. So let's just set this. So H plus, the ionization constant for water is 1 times 10 to the minus 14. The concentration of the base. Also remember also, sodium hydroxide is a strong base. So just like with strong acid, whatever the concentration of a strong base, that is also the concentration of the hydroxide ion. So this is a strong base, not a weak base. So the concentration of the base is the concentration of the hydroxide ion. And when you work out this, you should get 1, let me do it again, times 10 to the minus 12. Yeah, 1 times 10 to the minus 12. All right, so that is your hydrogen ion concentration. So you can go ahead now and say pH is equal to negative log negative log 1 times 10 to the minus 12. Guessing the right hand side is looking pretty better now. I mean the left hand side. But I'm just showing you the two ways. So this is much easier. All right, but I'm showing you both of them still. So the answer you should get here is 12. All right. So again, if you want the pH of a basic solution, strong base, you work out in this case, you work out pOH and subtract it from 14, and that is it. If you want to do it like this, you transpose the formula for H plus concentration. Once you get it, you log it, and that is it. Right? So that's pH of a strong base. Let us do weak base next. All right, so this calculation with pH of weak base, so we're going to do pH and Kb again. So just like with weak acids, once it's a weak base, it's an equilibrium reaction, and so you will have an equilibrium constant. In this case, it is Kb, the base dissociation constant. All right, and so if you need to find Kb, it's products over reactants. Again, just like with weak acids, concentration of these two are equal. So we don't need to put both of them in our equation. We're just going to put OH squared. All right, so it was OH minus squared. So when I put a base in the water, it abstracts a proton from the water. That is why you have Na3 and the OH ion. And we do not include water in our equation. So it's CH3 and H2. Right, so it's products, which we just use OH because these two are equal, as I've explained in the acid video. All right, so we need Kb. We have the solution. We have the concentration of the base. They gave us the pH. Right. So if they gave us the pH, we need. Let me see if it was pH or pOH. Right. So it's a pH of 7.64, and they want Kb. So to get Kb, we need the hydroxide ion concentration. So if you have pH from part 1, we know that we should antilog the pH to get the hydrogen ion concentration. So what we want is the hydrogen ion concentration. So there's two things you could do. All right. So let's start. So we know that pH plus pOH is equal to 14. So the pOH is equal to 14 minus 7.64. That's 6.36. So the pOH is 6.36. So if you antilog the pOH, you will get the hydroxide ion concentration. So remember, the hydrogen ion concentration, if you wanted it, you could antilog the pH. So since we have the pOH, we can antilog it and get the PO and get the hydroxide ion concentration. So it's antilog. Remember, it's antilog negative pH. Antilog. Just pause it and work it out. All right, so after we subtract the pH from 14, we get the pOH, antilog that, and it gives us the hydroxide ion concentration. And so we just plug it into the formula now for Kb, and we get our answer 1.91 times 10 to the minus 11. All right. And there's a minus sign. All right, so it's negative 11 and not just 11. All right. Secondly, what you could have done, remember this is pH, so we could get the hydrogen ion concentration. Reason for that. So where would we want to find the hydrogen ion concentration? If you remember the formula, Kw is equal to H plus concentration times the OH concentration. Kw is a constant. All right, its value 1 times 10 to the minus 14. So if I want to find the OH ion concentration, it is simply Kw divided by the hydrogen ion concentration. All right. And we said that the hydrogen ion concentration now is antilog of the pH. Antilog. Let me just pause again and work it. All right, so this is the next way of getting the hydroxide ion concentration. So anything that you need to link the hydrogen ion concentration and OH, you can use Kw, or you can use the pH plus pOH, right? Because you can always antilog any of them to get the concentration of it. All right, so when I want, so this calculation, we are doing KB from pH. All right, so we can just title it KB from pH. So let me just put it. So this is what you do if I want KB from pH. So that's KB from pH. All right. So now we're going to do pH from KB. All right. All right, so what I'm going to do for this, we're going to erase the pH. All right. So we're going to keep the question. All right, so we don't know what the pH is. All right, so a solution of methylamine of concentration 0.01, all right, as the base. All right, let me just write it. So, all right. All right, so this time I give you the concentration and the KB. So it's the same question, remember? I give you the pH and this concentration, and we got this for KB. So that means we should get back the same pH of 7.64, I think it was. All right, so you have the KB and you want the pH. So what we need to do is work out the hydroxide ion concentration. So we would know that if we transpose this, the hydroxide ion concentration should be equal to the square root. It's just like with Ka. So the hydroxide ion concentration is the square root of Kb times the concentration of the base. That is CH3 NH2. I'm going to pause it here and finish working it out. All right, so there we have it. We have the hydroxide ion concentration. And if you remember, it was the same. All right, so see, we get it back here. So the first thing I do is transpose for the hydroxide ion concentration. Once you have that, you go ahead and you calculate pOH. So that's negative log 6.36. And so now pH is equal to 14 minus pOH, which is 6.36. .64. All right, so there you have it. So if you are given, so this one we want KB from pH. No, this one is pH from KB. All right, so this is what you do when I want pH from KB. If you want Kb from pH, when you're given the pH, you antilog it, all right, and antilog it, that would give you the H plus, and then you figure out the OH from that, if you want to use Kw, all right. So over here was Kb, over here is pH, all right. So that is where I'm going to stop this. If you have any question, you can leave it in the comment section. So the other video from this now is past paper questions.